Okay, so still working on Lewis structures, let's look at the Lewis structure of a polyatomic ion. Let's use the carbonate ion as an example. Okay, so carbonate is one of the polyatomic ions that you're responsible for. Carbonate has a formula of CO3 2 minus. Remember what this 2 minus means. Remember this 2 minus means that we've gained 2 electrons. So we're going to add these 2 electrons to the total number of valence electrons because the charge on the ion tells us if we've gained or lost electrons. If we had an ion that had a positive charge, we would remove an electron. So let's see what this means. So the first thing we want to do is we want to see what's the total number of valence electrons. So we want to see how many does carbon have, how many does oxygen have, and I have 3 of them. Then whatever that number is, I'm going to add 2 more electrons because it has a charge of -2. So carbon is in group 4 on the periodic table, so it has 4 valence electrons. Oxygen is in group 6, so it has 6 valence electrons. 6 times 3 is 18. So I have 4 plus 18 plus 2 is 24 valence electrons to distribute around this molecule. So let's see what we can do. So anytime you, first of all, you know the molecule wants to be symmetrical. Also, you put the atom with the greatest bonding capacity in the middle, which is carbon. Carbon wants to make 4 bonds. Oxygen only wants to make 2. So I'm going to put carbon here, and I'm going to put the oxygens around. So far I've used 6 electrons, 2, 4, 6. So now I am going to start distributing. 2, 4, 6, 8, 10, 12. 14, 16, 18, 20, 22, 24. So I've used all my electrons, and I realize that oxygens have all of their octets full, but carbon does not. So this cannot be the correct Lewis structure. So let's try again. I needed 2 more electrons than I had, because carbon didn't have any electrons to put back here to give it a full octet. So that means I know I need 1 double bond. All right, so I'm going to put carbon here, put the oxygens around again. This is going to be an example of a resonance structure because there's going to be asymmetrical distribution of this double bond. So let's just do this first and then we'll see what that means. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Carbon is full because it has 4 shared pairs, so 8. This one has 2, 4, 6, 8. This one has 2, 4, 6, 8, 2, 4, 6, 8. Pay attention that when there's a double bond here, oxygen only needs 2 pairs here, but this is a single bond, so oxygen needs 3 pairs. So everybody has a full octet. This is the correct Lewis structure. Whenever you are drawing the Lewis structure of an ion like this, you would draw it and then you would put 2 minus outside to say that this structure has gained 2 electrons because this carbonate ion has a charge of -2. Also, something else you need to show here are the 2 other resonance structures. So this would be the correct answer for drawing the Lewis structure for the carbonate ion. You've gained 2 valence electrons because the ion has gained 2 electrons. This has a resonance structure because there's 3 different places where that double bond can be. The double bond can be here, the double bond can be here, or the double bond can be here. All of these are equally correct, and it's like an average of these 3 structures, what's actually existing. That double bond is really being shared between those 3 positions. This is how we represent it. This is an example of a resonance structure, and this is also an example of a polyatomic ion. Let's do one more with a positive polyatomic ion. Let's look at ammonium. Ammonium is also, the ammonium ion, a polyatomic ion you're responsible for. Its formula is NH4+. So plus means we've lost 1 electron because it's positively charged, so we lost 1 electron. So let's see the total number of valence electrons. So nitrogen is in group 5, hydrogen is in group 1, and I have 4 of them, and then I'm going to subtract 1 electron because this has a charge of positive 1. So I have 5 plus 4 is 9, minus 1 is 8. So I have 8 electrons to distribute. So you put the atom with the greatest bonding capacity in the middle. Also, you want to make it symmetrical if you can. 2, 4, 6, 8. We're done. Hydrogen is full because it only wants 2 electrons and it's duet. So these 4 all have 2 hydrogens. 2 electrons. Nitrogen has 2, 4, 6, 8 electrons around it. So everybody's happy. This is the Lewis structure of the ammonium ion. The one thing you need to do is you need to put brackets around it with the charge to show this is the ammonium ion. It has lost 1 electron because it has a positive charge. No resonance structure here because there are no higher bond orders. There's no double or triple bonds. So these are examples of Lewis structures of polyatomic ions. The things to pay attention to here are that when you have an ion, that tells you how many electrons you've either gained or lost, and you need to represent that both in the total number of valence electrons, and you need to show it outside of the brackets when you draw the Lewis structure.